everybody. Welcome to today's webinar, Recovering from Summertime Toxicity Issues. As like the last few webinars, this is kind of going to be a Q&A. Definitely ask as many questions as you have. I would say while we're presenting, we're going to focus on ones that are more on topic first. But once we get past the presentation and we've addressed all the on-topic questions, just ask whatever you want. You can ask questions in the chat on the right side of the screen. Anyway, I'm Dan. I'm the Director of Wastewater Education here at Aquafix. I do a lot of our research and development and client consultation work as well.
And I'm Tyler. I'm one of the several technical service representatives here at Aquafix. I handle primarily Wisconsin along with a majority of the Western United States.
At any time during this presentation, you can click on the Handouts tab, which is next to the chat, and you can download any of the materials we have provided, so the literature on these products for one thing. If we discuss anything during our presentation that we don't have a handout for, definitely reach out to us and we'll be able to get you more literature as well. Working with Aquafix Laboratories, we're primarily a research and development and consultation lab. We do a lot of the work to develop products and make sure that they're performing well in wastewater treatment processes. And we do a lot of microscopy work, and we're expanding into doing more treatability studies for clients where we do a more in-depth study to kind of understand a problem that's going on and find creative solutions to address it. And we're also starting to do a bit more anaerobic work this year. If you have any questions about our lab services, definitely reach out. Another thing I wanted to draw attention to, if any of you are interested in working with us for some toxicity studies, reach out as well. I'd love to have somebody who's providing samples, who's concerned about toxicity in their wastewater system, so I can continue doing more and more research to understand toxicity better, so we can provide better options for treating toxicity in some cases for clients. All right, so today, as stated in the title, we're obviously focusing on summertime toxicity issues, which is always kind of an interesting thing because summer is usually a pretty healthy period of time for wastewater plants. Your bacteria are operating very quickly during the summer. However, this quick bacterial operation combined with the high temperatures can actually lead to a couple issues which have symptoms similar to toxicity and therefore can actually synergize well with toxicity, so you can get a lot worse toxic symptoms with a lot less biocide. And these dominantly are going to be low DO problems, and low F to M problems can make the likelihood of a toxic event in your wastewater plant a lot higher. Stress systems in general tend to have a more difficult time dealing with and recovering from toxicity. So looking into your process and understanding what the forms of stress are can help you make your plant more resilient to toxic upsets, reducing the likelihood that something like a quat, biocide, or a peracetic acid, or whatever other toxin might be entering your process is going to cause a problem. Here's a quick photo of a quat before and after. We were studying we were taking a video of how quat responded to, or stalk ciliates respond to quat being added to a microscope slide. So as the quat flowed through the slide, we could see the colonies start to shrivel up and die. We actually have a video on our YouTube channel here, which we're going to post the link to if anybody wants to check it out. But it's kind of interesting. A lot of these cases, we're going to see a lot of impacts on metazoa for toxicity specifically. They tend to be a pretty good indicator, and we'll talk more about that throughout the presentation. Next thing I wanted to draw some attention to, because this is a very common misconception. So I've done a lot of studies on quats and peracetic acid. And one thing to look into is if you have a larger population of active biomass, your system is much less likely to have a toxic upset. And the response to that in a lot of cases is maybe if we hold more sludge, we're less likely to see toxicity from a biocide. But that is not necessarily the case. And that's because mixed liquor suspended solids and mixed liquor volatile suspended solids are the dominant measurements people use to understand how much bacteria they have in their system. And unfortunately, both of these are considering dead bacteria, which make a large portion of your biomass up. And in some cases, undegraded substrates like proteins or fats could be included as well. Mixed liquor even gets like grit and sand and stuff. So you end up with your active biomass, if you were to take an ATP measurement, usually only being like 30 to 40% of your mixed liquor concentration. And sometimes when you hold more biomass, you actually notice the active biomass percentage will go down Therefore, holding more biomass is actually hurting your levels of bacteria rather than helping them. And this is something we see sometimes in the summer. I see this in the winter as well. People start holding more and more sludge, and that's helpful to a point, but you cross over a threshold where you actually have too large a bacterial population, it can't sustain itself well, and then it starts to die off and you lose a bunch of active biomass. So like I said, ATP is a good metric to understand active biomass. We've been starting to do that a lot more with some of our test kits if we think it's relevant to a case. And we're also working on live dead cell fluorescence microscopy, which you can see on the right side of the screen. So we can actually tag the cells. So in this image, the green cells are tagged as live cells, and the red cells are tagged as dead cells. And you can actually quantify this to get a sense for what percentage of the bacteria is alive in a system as well. Another key thing that I always kind of try to hammer in is Floc. Like, you can't have an activated sludge process without Floc. You need your bacteria to settle properly. Low DO, low F to M, and toxicity can all negatively impact your Floc, which means your settling will get worse, and in general, your system performance is going to be poor. So when we think about preventing toxicity, the goal is to make the Floc as good as possible so you have more room for error for an upset to not totally mess up your system. Floc make up a diverse group of bacteria, so you have different communities fulfilling different roles. It can kind of be interesting in a toxic event where you might see one community, like the nitrifiers, damaged substantially by a toxin, but the other communities are all fine, so you still see good Floc and DOD removal. Or you could see the Floc totally disintegrate, but actually still get good nitrifier operation. It's kind of interesting how different elements of the Floc might survive a toxic event, while others might not. So I'm going to start off talking a little bit about low DO, which we see all the time in the summer. That's because oxygen solubility in water is lower as temperatures increase. In addition to that, we typically see faster metabolic activity from wastewater bacteria during the summer, which means they're more likely to start to degrade the biopolymer, or EPS, in the system, which is like a glue that holds Floc together. It's also a stored food. If you hold too high a bacterial population going into the summer, it's going to start to, the EPS will start to get eaten away, but low DO makes a big impact on EPS strength and can cause more EPS diffusion, and it can cause poorly consolidated Floc. You'll also see low DO filaments in particular. So we have Thiothrix we see somewhat frequently, type S natans we see somewhat frequently. Those are two pretty well-known low DO filaments. Thiothrix has nice sulfur granules you can usually see under the microscope, and S natans is known for false branching. The other filament I see quite a bit is type 0 to an N, which is not as strictly a low DO filament as these two, but type 0 to an N actually can cause some pretty major problems as well, which we see more often during the summer. I touched a little bit on this in the last slide, but low F to M conditions can be particularly detrimental during the summer because your bacteria are working faster, they're going to eat away at the biopolymer, and it'll make your Floc all fall apart. And when the Floc fall apart, you lose a lot of helpful bacteria from your system, and you end up with a poorly functioning treatment. We see a lot of growth of low F to M filaments, which is a good indicator that the plant is being underfed. The other thing is going back to my previous slide where I was talking about active biomass ratio. If you're holding too much sludge during the summer, you'll see that active biomass ratio begin to drop off, and that's a good indicator that if you keep holding high solids, your Floc are all going to fall apart and your system is going to fail to operate as it should. Either of these problems lead to a similar looking situation, which is Floc disintegration. The Floc all break up because the EPS is destabilized or eaten. You'll have a lot more turbidity in your supernate leaving your plant. Your Floc are going to end up a lot more smaller and more spherical. And this can be a little bit confusing because this is also something you'll see with toxicity, and it can happen kind of out of nowhere. So how do you decide if it was a plant operational thing causing the problem, or if it was a toxin causing the problem, or if it was a combination of both? Like, it's really hard to tell because the symptoms tend to be fairly similar looking in terms of what you'll see in a large-scale plant on site. I talked a lot about the live dead cell counts and this kind of thing. I went over the slide a little bit just now, but there are a couple good ways you can tell if something is likely a toxic event rather than if this something was just a low FDM or low DO issue. The best indicator for me is actually, first of all, you're going to look for an absence of low DO or low F10 conditions, but those could be present at the same time as toxicity, so that doesn't allow us to dismiss it. The next thing I would look for is a rapid increase in dead bacteria you can see in the system. So looking at our live dead cell photo, you'll see much lower active biomass as well if you take that measurement, because you'll have a lot more dead bacteria. But in addition, we'll typically see quite a bit of dead stalk ciliates or colonies that are headless, that kind of thing. And you'll also see more dead metazoa, like dead rotifers typically tend to be present in toxic conditions. Now, interestingly, I often do see live rotifers and live stalk ciliates in flasks when I nuke them with the biocide with like quat, but they tend to decrease in quantity and you'll see many more dead metazoa and protozoa in a toxic system. So here's just a couple photos. We have our headless stalk ciliate colony on the right. You typically see smaller, more fragmented floc on the left. The other thing to consider is if you have a major toxic event, if you're to look at it under the microscope, one thing you'll see that you won't see so much with low DO and low F10 conditions is a dramatic increase in free bacteria in the bulk liquid. Because when you have a toxin enter your process, you actually end up with an excess of food because the bacteria in your system are broken open and all the nutrients contained within those bacteria can be more easily consumed by the other bacteria. So you get this spike in high free bacteria you'll see virtually after every toxic event, which gives you a good sense of whether it's toxin impacting your system as opposed to something like just low F10 or low DO. Another thing to consider, let's say you've been dealing with what you think is toxicity for a large period of time. How do you measure what impact it's actually having on your system and what sort of changes you might need to be able to understand if you can overcome the impact of that toxin? And one good way to do this is with oxygen uptake testing or specific oxygen uptake testing. Main difference between those two is specific oxygen uptake testing takes account solids in your sample, whereas regular oxygen uptake testing is just measuring oxygen levels over a period of time. But they're very similar measurements. You can also do some nutrient uptake analysis and ATP analysis, and these are helpful. Particularly the nutrient uptake analysis can be really helpful because you can look specifically at what your effluent limit concern is and see if you can find a way to address that rather than kind of addressing everything like you'd be doing in an oxygen uptake test. You're just looking to see if your bacteria are able to metabolize faster, as opposed to, am I specifically removing ammonia as I intend? So here's an example. I was doing a quick study on impacts of quats with oxygen uptake rates. What you can see here is as you increase the dose rate of quat, we end up with a slower uptake of oxygen, which means the bacterial population is operating more slowly. And you can actually take the slopes of these lines and get a good sense for how much of an impact is the biocide actually having on your system. And is it something at the application rate you're applying that you can easily overcome by making a small change? Or is it something where the biocide absolutely must be eliminated from the waste stream? This is really nice if you know what the likely toxin is. You can collect a sample and you can run an oxygen uptake test if you have the correct setup with. We are able to do that testing. If anybody has any questions on how to run it, or if you'd like us to work with you on running this type of test, definitely let us know. But yeah, if we get a sample of a biocide, we can try to add things to it to see if we can overcome toxic symptoms. And we can also get a sense for how close your system is to being able to withstand the toxicity, which can help us approach what solution is, if there's just some minor operational tweaks we can get past it, or if it's really a bigger issue. So how do we prevent toxic upsets? Going back to before, the first thing you're going to want to do is make sure your plant is as healthy as possible when there's no toxin entering the system. A healthy system can withstand a lot more toxin than an unhealthy system. In my internal tests on quats and PAA, I've seen some systems that are able to handle like 30 parts per million of quat, no problem. Like, especially my lab mixed liquor did that a lot. I'd see absolutely no symptoms from toxicity at 30 ppm of quat. But if we deal with some systems that were a lot less healthy, we start to see problems with quat toxicity in the 5 to 10 part per million range. So you can see it can be pretty dramatic how big an effect just having a healthier system is on how toxic biocides are to your system. Of course, there is a lot of value in looking upstream to where the toxins are coming in and trying to understand how they're being discharged, if there's a modification for how the toxins might be dumped down the stream that can allow you to not have as big a concentration as once. That can be really helpful. Or I've looked into biocides a lot, and to some extent a diverse group of, like, for example, if you were to just use QUAT or just use PAA in an industry as a disinfectant, individually, at a high concentration, they're likely to damage the plant. Whereas if you were instead to use a lower concentration of QUAT and a lower concentration of PAA, you might still get good disinfection upstream, but you'd be less likely to have an issue with the plant, because several of these toxins don't have any combined impacts. Like, you reach the threshold on one and there's a problem, or the other and there's a problem, but having a low dose of each tends to not be a big deal. So there's a lot of options when you're looking at the source of the toxin, if you're able to have good communication with that place. Often with municipalities, I know this can be a struggle. Nobody wants to fess up to who dumped the QUAT down the drain. But industries, very often, if they're having problems with upsets routinely from toxicity, if you're communicating and have a friendly relation with the production or wherever they're using the disinfectant, you might be able to make an arrangement which works a lot better for your site. Another thing I want to draw attention to quick is there's a lot of these QUAT test kits on the market which are pretty simple and quick. I've worked with these a little bit, and they are not very reliable when looking at mixed liquor samples. They tend to be okay if you have a high concentration of QUAT or something upstream. But if you're looking at your actual plant, there's so many different things that can interfere. You don't have a sense for what QUAT or whatever other biocide you're dealing with is actually a problem. Like, you might have inactive QUATs, you might have QUAT species that aren't actually biocidal, and then you'll have the biocidal QUATs, and you may also get interference with things like ammonia in your system, which can lead to these numbers being really confusing and misleading.
All right, so now that Dan has kind of identified the both drivers and symptoms of different forms of toxicity, I'm going to quick run through how some of our treatments can help either aid you in mitigating future toxicities or simply just recovering from past toxic events. One of which, especially pertinent to summer months, is our OxyFresh. So as Dan noted, DO is a pretty common issue, especially in areas that do receive a pretty significant increase in temperatures throughout the summer. So low DO is one of the issues we frequently come across in middle to late summer. So right here on your screen is our OxyFresh. It's a pretty straightforward product. It's really just a blend of liquid oxygen. So if either your lagoon or wastewater plant does not have proper aeration, or you simply can't get enough aeration in the basins with what systems you currently have in place, OxyFresh can simply help you get over that hump. Basically bridge the gap from middle summer to about early fall. It's going to reduce any sort of septicity in whichever area you're applying it to, as well as reduce the risk of any type of low DO filament occurring. So kind of going into more specifically toxic related events, as Dan said, really the biggest thing is we want to get proper floc established, especially after a toxic event. CounterQuat would be the first part of that process in applying a modified food supplement that CounterQuat is. It's able to build the polyprotein matrix around the cells a whole lot better than they would ordinarily. Thus, should any toxicity come through, or if there is any residual toxicity lingering in the system, your bugs will be protected from those upsets. Looks like we got a question that is pretty pertinent to this specific topic. So what is your opinion on QUAT binders and products like them? I can't necessarily comment on the efficacy of different types of QUAT binders, anything like that. Typically, we have no issue in plants using them. It just as the dosing does get a little finicky with the QUAT binders, especially if you are receiving high amounts of, not only QUATs, but different types of toxins. So what CounterQuat then could do, if you are using a QUAT neutralizer, is it'll help protect the bugs from any, residuals that maybe that QUAT killer, it doesn't exactly bind up. Some may get released. CounterQuat will help clean that up. Or in most cases, we see, a lot of upstream connections, or if you're at an industrial facility, who knows what type of cleaners they're using. Sometimes they'll switch without notifying those downstream. So CounterQuat will not only help protect against QUATs, but also other forms of toxicity as well.
Yeah, I have, just to interject here in quat binders, I have done some studies on them, and one thing to consider is quat binders typically are going to be relying on some sort of anionic polymer, which the quat will stick to. Quat is a positively charged molecule, and when they stick together, the quat is inactivated, and it's going to not impact your system ideally. So in practice, what this means is you really need the quat binder to come into contact with the quat. And quat needs to have a preference for coming into the quat binder versus other things in the system that the quat might also like to stick to, like a bacteria. So in practice, quat binders can work pretty well if they're applied upstream where the quat is being discharged, so there's not a lot else for the quat to stick to. There's some time for them to interact and stick together, and the quat can be inactivated before it hits the plant. But using it in a plant directly tends to be pretty ineffective because there's not a lot of guarantee that a quat is going to decide it wants to stick to a quat binder. I say decide, these are molecules. To be clear, molecules don't make any decisions, but the quat will stick to the quat binder or it'll stick to bacteria, whatever happens to be closer, kind of thing. So you can imagine in your aeration basin, let's say you have 2,000 parts per million of bacteria in your basin and 10 parts per million of quat binder. What do you think the quat is more likely to stick to most of the time? And I have had a couple comments back and forth about quat binders having adverse effects on the system, but I've looked into that personally, and I haven't seen any evidence that they necessarily hurt wastewater bacteria. And we have measured some quat neutralization with adding quat binders, so I'm not saying they don't have a place, they don't have a purpose, but generally in your wastewater plant, once the quat is already there, they're not a great application. The other thing to consider is they work really well if they're interacting with the quat, but if you're continuously metering in quat binder upstream, and the client is only using quat once a week that they're discharging down the drain, most of that quat binder is going to be wasted. So you have to consider timing on them as well.
So now that we kind of set the stage in recovering from toxicity, we'll move kind of further down the recovery timeline. So after CounterQuat usage, when you know that either the toxicity is you've gotten it stopped dumping on you, or it simply made its way out of its facility, now you really want to focus on further rebuilding your flockers. So rebuild, our Vitasim rebuild, is going to supply additional bacteria and nutrients to the system to get those flock formers moving and growing a whole lot quicker. It works very well in tandem with the CounterQuat because the CounterQuat provides a food supplement and helps build that bacteria a whole lot quicker, and then rebuild can really finish off the rest of the flock formation, at least in that stage. It's going to be excellent at removing different types of nutrients such as BOD, ammonia, and phosphate. So if you're looking at starting up your process, rebuild is a good viable option for you. And once again, moving kind of further down the treatment timeline, now that flock formers have been established, that toxicity is gone, really all that's missing is the ammonia removal process. So our dynamic duo, as you see here on our screen, is going to be one part of our nitrifiers, the bacteria that's going to be specifically doing the ammonia removal, and then our ammonia simulators, which we use to basically act as a glue-like substance to adhere the nitrifiers better to the flock that you have now established. This one is a little different than most of our products since it does ship out overnight. They do need to be refrigerated when not in use. Just because, as you know, nitrifying bacteria is particularly temperamental. So we do take the extra precaution to make sure they do remain viable. So now that we've kind of worked through the whole timeline and how to recover your treatment process, or at least build a little more tolerance to it, to any toxicity or really any upsets. On your screen now is our microanalysis and filament organs test kit. This is our standard activated sludge test kit. And what we do, if you aren't familiar with our testing services, is we'll supply you with 2 very small sample bottles. What you'll do then is sample your mixed liquor from your aeration basin, SBR, whatever basin does most of your biological work. From there, we'll take that and we'll be able to image the flock, either doing phase contrast, looking at oxygen penetration, which is especially pertinent in summer months, all the way to doing staining and filament identification. From that, we can get you personalized recommendations based on what we find being the most problematic in your system. and provide you with a written report within about 2 to 3 days of receiving your samples. Now, as Dan noted earlier on, is ATP testing is a big facet of how you are able to really identify and almost quantify different types of stressors and toxins on your system. We do offer the microanalysis test kit in a pack of 4 called the Proactive Microanalysis Test Kit. And what it is a pack of 4 for a lot cheaper of a price as compared to just buying individual test kits. But you do also gain the ability to get ATP testing provided by our lab, including other biological stress indicators and all that fun stuff. So you're able to really track how your treatment and how your process changes and adapts over time.
Yeah, and just one other thing to add about these microanalysis kits tend to be a really good way to assess what things might be negatively impacting your system health or how the system health is. But if you're sending us a sample, typically these will always be helpful for aerobic wastewater samples. But if we diverge more into anaerobic samples or like outside of the plant lift stations and things like that, definitely reach out to us first. It's possible we'll be able to do something helpful with them. It's possible we won't be able to, and we just want to make sure that if you send us a sample, we want to make sure we're going to be able to do something useful with it. So aerobic systems, we typically are comfortable looking at pretty much anything. But if it's outside of an activated sludge type system, then you're going to want to check with us before you send it in.
And here we got a question from John. So yes, ATP analysis is part of the proactive microanalysis, so that 4-pack of kits. In the individual one, we don't offer that. So if you are interested in ever doing any sort of those stress indicators or ATP analysis, definitely look into our proactive microanalysis kit. We can't recommend it enough, especially for very seasonal treatment plants. It's a great way to get a checkup, each season to see how your plant responds to different temperature changes and really any environmental factors. It's basically like going to the doctor.
Just a note on ATP, having one ATP measurement on a single test kit tends to not be very useful because you have no idea what your ATP normally looks like. And it's not that consistent from plant to plant. It's going to vary dramatically depending on what kind of pre-treatment you have, what type of waste stream you have, and other environmental conditions in the site. So we want to be comparing your plant on a good day ATP to your plant after the upset so we can see how much of an impact on ATP the upset has actually had.
Since that is the last, we can roll into the questions portion of this webinar. And we'll start off here with the question on your screen. How long should I wait to add nitrifiers after a toxic event? So kind of moving back to what I talked about in that treatment timeline is, first we want to set the stage. Number one, make sure that any toxicity that came through or really whatever caused that upset that led to a loss in BOD removal, TSS, ammonia removal, that sort of thing. We want to make sure that has either been fixed mechanically or the toxicity is simply no longer in the system. So once that's achieved, you'll start to see BOD removal start to recover back to what you're historically used to or what your plant typically operates at. And then you'll note some improvements in TSS. Those two coincide very closely with one another. Once that's established and you feel comfortable that your plant is removing proper amounts of BOD, then we say the nitrifiers are really basically the icing on the cake, so to speak. That's about when we'd expect successful nitrifier rehabilitation. And it's only about a 10-day treatment. So once you're able to properly remove BOD and you have no other issues like low DO, low pH, anything like that, then we fully expect a complete nitrifier rehabilitation. While we're waiting for some questions, we'll take you over here to our YouTube channel. We'll post the link. This is the video that Dan had talked about just on the impacts of on stock. So, all right. So where is the best place to add CounterQuat?
I would definitely say, so CounterQuat generally is going to work best added directly to an aeration basin because it is formulated to work with the bacteria in the aeration basin for them to protect themselves better from quat. It also is helpful in helping bacteria recover after a toxic upset. It tends to stimulate a lot of new growth with the nutrients that are included in CounterQuat. So, but if you add it upstream, it tends to be a pretty easy to eat substrate for bacteria, which means a lot of it isn't going to make it to the system in as many cases, which means it won't have as big an impact on toxicity if you add it further upstream. So that's the one thing to watch out for with CounterQuat. Out of curiosity, if anybody in the chat is, do you have any biocides you are particularly concerned about, or any interesting toxins that we might be able to talk about? Obviously, we've done a lot of work with quat and PAA, but there's a lot of other options, and there's also sort of specific incidents which might be interesting to discuss a little more.
Nathan asks here, how would you dose the OxyFresh to treat a plant versus a lift station to handle the odor? So lift stations are going to be a little variable when talking about odors. It could be a different number of things, whether it's just simply the substrate that's passing through, or if it is in this case low DO issues, or if there is any kind of toxicity rolling through. Typically, what we would do is, number one, look at DO levels in a lift station. If they are particularly low, it's pretty safe to assume that that is simply the cause of the odor. So for that, we would recommend adding the OxyFresh in directly in that lift station, or just upstream. You can either meter or slug, simply just to boost those DO levels and offset any septic odors, or really any issues that, that come along with septicity.
Got two more questions here. One is the effects of long-chain fatty acids. That's a really interesting one. I've done a little bit of research in long-chain fatty acid toxicity. And the tendency is that can be a problem if you have a very high concentration of fats. The fats actually can coat the outside of the bacteria, preventing nutrient exchange and proper bacterial function. Generally, that's going to be very high concentrations, but yeah, they're kind of going to starve out the bacteria. And we see that sometimes in like anaerobic food processors where they're loading very high amounts of grease into a digester all at once. I haven't seen too many toxic impacts in like an aeration base and that kind of thing. I'll take this next question as well. Do you recommend using, I assume you're talking about some sort of sodium bisulfite or something along those lines here. Yeah, that actually works pretty well to reduce PAA impact. I found sodium thiosulfite and sodium monobisulfite both worked really well for reducing the impacts of PAA. It substantially increases the deactivation rate of PAA. That's always going to be a big thing with PAA. It decomposes, and once it's decomposed, it's no longer an impact for the bacteria. This can happen naturally if you have a lot of time in an EQ tank or that kind of thing. But if you add something like sodium monobisulfite, it'll happen faster, so you don't need as much EQ time to prevent PAA toxicity.
And that actually really closely ties into what concentrations of quats coming into a treatment plant do you see that cause toxicity, and does it depend on what kind? So
there's a bit of a range of toxicity from different quats, and we haven't been able to like test all of them so we can say exactly how toxic certain quats are. I've done a lot of work with benzyl colonium chloride specifically, which is a standard I've seen in a lot of research on quats. That is a strong biocidal quat. Typically something like that, and I've also used a consumer product. I was using MultiQuat 455 for a lot of studies, which is a hydrate compound. It's about 7.5% quat. And in both those cases, I was seeing toxicity usually on nitrifiers around 10 part per million, but the floc would still remain healthy and intact. And if you went to 20 to 30 ppm, you started to see floc forming properties deteriorate a lot more strongly, and you'd see a lot more turbidity. But there are cases like I've done work on, municipal plants tend to be a lot more resilient to quats than like industrial plants because municipal plants have a more diverse bacterial population. So you've got a lot of opportunity for different organisms to kind of pick up the slack. But when I've worked with like dairy samples, it's been more like 5 ppm we start to see problems with ammonia removal, and like 10 we start to see problems with heterotrophs. It's significantly higher sensitivity. And that also goes along with the tendency for higher loading rates in general. Like in a municipal plant, you might have a couple hours of extra time, whereas in an industry, you're kind of loading as much into your plant as you can a lot of the time, so you need more time in general too. So those factors kind of compound. So the toxicity of quats can vary a lot depending on site and likely species, but I haven't looked enough into that to know what each species might have for an impact at what point. Oh, we got another question. Why don't you take that one, Tyler?
Is there anything I can do to help my plant withstand higher flow rates during holidays or other high volume weekends? Yeah, certainly. So obviously when you have high food coming in, you want to balance that out with a high level of bacteria. So one option is you can either hang on to a lot more bacteria. That does get a little finicky in some aspects. Sometimes operators can simply hold, too much mixed liquor and it gives way to an older sludge age, thus leading into other kind of filament issues. Or you can simply just, if you do know there are specific times when you do receive a higher feed rate than normal, you can simply just add in more bacteria. That's actually where that Vitasyn rebuild comes in handy in those situations when you don't quite have a long period of high loading, but you just need to overcome, brief stints, week period of times, that sort of thing. Other than physical removal, is there a product to reduce settled sludge buildup in an oxidation process? Yeah, so one of our products actually wasn't talked about in this presentation, but we do have Sludge RX. What it is a tableted bacterial supplement, simply just scattered in any aeration process, lagoons, aeration basins, oxidation ditches. Can be used in a variety of different situations, but all it takes is simply just scatter the tablets across the surface of the water and let the bacteria go to work. They'll be able to physically reduce the sludge without having to do any sort of physical dredging or altering the status of your treatment system. You don't have to take basins down, nothing like that. You can simply just add during operation and it'll go to work on the sludge.
Yeah, it brings up an interesting point, though, that comes into a little bit related to next question, too. We talked about low DO in my presentation, or in this presentation. Sorry, Tyler, it's not important here. But now, in the presentation earlier, I talked a little bit about low DO symptoms and their impact on Floc. Technically speaking, settled sludge in a basin can be a cause of the low DO symptoms, which can serve to stress out Floc. So if you feel like your DO is high, but you have low DO symptoms, this sludge in your basin might be something you're going to want to consider. All right, the next one is, do you find that plants receiving septage from outside haulers are the primary cause for toxicity issues in plants? Primary cause, I would say outside haulers are frequently groups that industries we work with and other plants are suspicious of for discharging toxins. And I think there is some merits to, you don't necessarily know what you're getting and each load of sludge that way. So they do have some potential to lead to upsets. The other thing is septic waste in general is going to be stressful on an aerobic wastewater treatment system. So this might be a case where if there's a little bit of a cleaner or a detergent in the septic waste, it might interact in a way with the other low DO type problems that are associated with septic waste in a way that has an impact on your system. But yeah, it's always very hard to pinpoint this because if you're dealing with a bunch of trucks coming into your process, you don't necessarily know immediately which one's causing the problem. And I don't necessarily want to point to septage haulers specifically as being like the main problem, but I do think we've seen some issues from them at least.
Oh, here's a good one. All right, what should I look for under the microscope when I suspect toxicity in my influent?
I think that an increase in dead metazoa and protozoa can be a very clear indicator of toxicity in some cases. So you might rarely see any dead rotifers, and then all of a sudden you're seeing like 30% of your rotifers are dead. That's a pretty good indicator. Typically, Floc will break down for being large, sturdy Floc into smaller Floc fragments in events of toxicity. There's a number of reasons this could happen. Part of it is damage to the EPS structure. You might have some impacts for a biocide damaging filaments inside the Floc, which can actually weaken them. There's a number of things that can go wrong there. But the other thing is high levels of free bacteria typically happen immediately after a toxic event because, like I mentioned before, you're releasing nutrients when you kill bacteria. This will cause a high F-time condition in your process where you're going to get a bunch of rapid growth.
And once again, I should just add, as always, if there's anything you're not, entirely confident looking at under the microscope, that's really where our services come in handy the most, is being able to, contact us, get yourself a lab kit, send us samples, and we'll be able to confidently identify, any types of stressors, filaments, all that sort of thing.
I have another question about the live dead cell microscopy. So I would say if you can send me an email, this is which is dan.s@teamaquafix.com. I think it's somewhere in the chat, or it's getting posted right now. We can send you what we use specifically. That is actually a kit. It's actually a very easy stain. The challenge is you do need a fluorescent microscope, which is not very accessible for a lot of people. But yeah, that's an interesting technique. We're working on expanding more into that. But yeah, it's two stains, and basically you're staining everything red, and then you're adding a green stain which reacts specifically with live cells, so you can get that contrast. And yeah, we're working in general with fluorescence microscopy a lot. We're going to be working more into fish to look at things like nitrifiers specifically and how their abundance decreases for toxicity too. But yeah, the live dead cell kit is actually really nice and simple to use if you have a fluorescent microscope. And if you want to know more about that, definitely send an email. All right, well, thank you everybody for joining us. If you have any questions you think of after the presentation, feel free to send out an email. Have a great day.
Thank you, everyone.